So some of you are smiling. I think in a minute you'll hate me. So I have mixed messages. Well, actually, good news and bad news. The bad news is on current trajectory, most of us here today will not be able to live to our full biological lifespan potential. So that's some grim opening. And as we speak, there's a huge fire going on in Australia. And disasters like this is only going to amplify in the coming months and years. But the good news is that we actually have to the best of my knowledge, one solution that still exists that entails using the most abundant and ubiquitous materials we have on Earth to tackle this planetary scale problem. Anything high-tech, we just don't have enough of. And the problem is created by each and every one of us. Here in America, each of us spit out 1 ton of CO2 every 3 weeks. That's huge. And the good news is that using the cheap materials, it's possible to negate the heating effect of that CO2 at the cost of less than $10. But first, we need to be really honest about several facts. First, we will settle once and for all that climate change is real. But second, maybe a bit of a shocker for people here, we actually cannot let go of the fossil fuel industry immediately. We are literally addicted. And third, if somebody tells you that renewables are a solution, they're lying to you, just as are the climate deniers. All right, so climate deniers like to say that Earth has undergone a lot of natural fluctuations as an argument that everything that's happening is natural. So that's what Earth did in this CO2 temperature plane before we started to burn coal in 1750. And it's going around, but look at the logarithm time scale. The motion is very slow. It moves a little bit over like 1,000 years. But ever since we started to burn coal, we have accelerated the movement by more than 2 orders of magnitude in speed. So that's certainly not natural. So that's settled. And this trajectory is bringing the Earth system rapidly out of parameter space that life on this planet can survive. So plants certainly do need CO2, but at a height too high of this concentration, then animals will start to feel the acidity and die off. On the temperature axis, even 1 degree Celsius can be too much for certain species. And the 2 degrees has been shown to be basically universally detrimental for most experimental systems that's been examined. And at 3 degrees C, we're talking about planetary scale biological annihilation of any multicellular species on this planet. So we obviously have like 2 boundaries that's limiting what can happen in the future. One is the temperature boundary, the other is CO2. But on current course, we're gonna hit the temperature boundary way before the CO2 intrinsic acidity effect. And in fact, even if we burn all the fossil fuel reserve, we won't get there. So the only thing we need to be worried about is the temperature effect. We desperately need a way to gain negative mobility on the temperature axis. So that's what we need to achieve. So now we're ready to discuss why we cannot let go of the fossil fuels. So when we burn fossil fuel, we emit CO2, but also aerosols that can scatter light. And part of the sunlight gets reflected back into space. And the amount of cooling is substantial based on best studies and simulations. It's about 2 watts per square meter everywhere on Earth. And that translates to about 1 degree of heating if we removed all fossil fuel emissions and the consequent aerosols. So those are papers that you can consult if you're interested. So assume that we go into 100% renewable as of today. What would happen? First of all, removing aerosol will pretty much, within 5 years, give another degree Celsius rise in temperature. And thereafter, the rise in CO2 and temperature will be slower compared to fossil fuel economy, but it still happens because the infrastructure still takes energy and resources. And a certain technology like wind generate heat due to friction loss in its energy generation process. So solution, these are not solutions because it doesn't give us a mobility vector pointing down to lower temperatures. So the solution is to use the MEERs in order to cancel out the heating trapped by CO2. And 1 ton can be canceled by 8 feet by 8 feet squared installed in a sunny area. Glass is wonderful because you take sand and sunlight, you can make a glass, and into all different kind of shapes, and it's strong as an engineering material. So the plan is to, 1, stabilize temperature as fast as possible by making glass MEERs, install them in the ocean on deserts at the cost of 50 to 500 billion. And second, once we have a huge glass manufacturing infrastructure, we should push for high penetration of concentrating solar thermal energy, getting rid of further CO2 emissions. And then finally, we can talk about drawing down CO2. For example, if you take oyster shell, just heat, then you get calcium oxide, which then you can scatter into the ocean to neutralize CO2 that dissolves into the ocean. So here is the roadmap to on how to survive the next 50 years.
Thank you.